Beneath its swirling clouds, the third planet from the Sun is a world of remarkable diversity. But how well do we really know it? Is unique amongst the planets in that it's almost entirely covered in a liquid which has changed its course of evolution. This planet also has life, and in such astonishing variety. We take life for granted, but why is it here? And as far as we know, only here. Jeremy Cherfis is a zoologist who is still searching for the answer. So Jeremy, as a zoologist, how did all this life get started?
Well, it all really depends on the Earth being just right, just the right distance from the Sun, so that water stays as water, it doesn't freeze into ice, it doesn't boil into steam. Once you've got water, all kinds of chemical reactions can go on there. We get what we call a primordial soup, and out of that, the first life began. We don't know exactly how.
Somehow, though, life did evolve. Not life as we know it today, but primitive things like bacteria, the forerunners of plants and animals. And as it did, it changed the world, mostly by changing the atmosphere.
In the early days, there was probably far more carbon dioxide than we've got at the moment, and much less oxygen. In fact, there was probably no oxygen. But the plants converted carbon dioxide into oxygen. Then the animals were able to evolve, able to breathe the oxygen on which we now depend. It's a funny thing, but the plants made it possible for us to live, and now, of course, we eat them.
So animals and plants depend on each other for their existence. But neither could survive without one vital ingredient. Our water-laden atmosphere also helped shape the blue planet, our planet. Rivers, oceans and streams are constantly eating away at its surface. The Grand Canyon has to be the most mind-boggling example of the power of erosion anywhere. It's amazing to think that only 6 million years ago, the Colorado River was a tiny stream flowing across the flat Arizona deserts. And since then, it's cut down through these soft sandstones to create this, the most colossal canyon system anywhere in the world. At the same time, the Earth is continually rebuilding itself. New mountains are spewed out of its belly. Our dynamic living planet is in a state of constant change. The face of the planet is changing on a global scale. Victorian geologists notice that the continents fitted together like a giant jigsaw puzzle. They thought that millions of years ago the continents must have started floating freely across the surface of the globe. But they couldn't explain how giant land masses could float, divide, and even collide, forcing up enormous mountain ranges where they did. Continents in collision. It seems absolutely absurd, but it's not. And thanks to the work of Drummond Matthews and his colleagues here at the University of Cambridge, we now know that the continents actually drift around the surface of our planet. Drummond, how did you prove the Victorian geologists were right?
Well, in 1961, I was working across the Indian Ocean, which we didn't know half as well as we do on this map at that time. And I was measuring the magnetic field of the Earth. That's the field which makes the compass point north at the present time. And we already knew in this slab that the field was liable to reverse, that the field coming from the middle of the Earth was liable to change its direction rather suddenly, so that the compass would point south instead of north. And we did some work here in the Indian Ocean. I had a very brilliant research student, Fred Vine, who was here, and we interpreted this story as if the ocean crust was moving away from the crest of the Carlsberg Ridge, which is this bit which we had discovered. The crust was being magnetized just like a tape recording is magnetized, alternately normally and reversely magnetized.
Either side of the mid-ocean ridges, Drummond found parallel strips of seafloor bearing alternating magnetic imprints. Here was the vital clue. The strips were formed during different geological periods and magnetized according to the direction of the Earth's changing magnetic field at the time. But where did the strips come from? Drummond realized the ocean ridges themselves were constantly oozing molten rock. The rock becomes new seafloor, slowly making the oceans wider and pushing the continents apart. Usually, the oceans widen silently, but fireworks blaze when undersea volcanoes erupt, rapidly building up temporary and sometimes permanent islands along the ocean ridges. It's here that the Earth is cracking up. These huge cracks divide the world's surface into a moving mosaic of enormous plates, each measuring thousands of miles across. The jigsaw pieces are larger than we thought. Thanks to Drummond's research, we found the continents actually travel the world on huge slabs, plates floating on the molten rock below. And they're all moving in different directions. It's called plate tectonics. When plates collide, something's got to give. Mexico City, autumn 1985. Thousands of people are dead and millions more are homeless as a result of a slight brush between the North American plate and the small Cocos plate. We might be able to avoid such tragedies if we knew exactly how the plates moved. What is it that drives them?
Well, I think the proper answer is that we don't know. The theory of plate tectonics is a theory which tells us how the plates move at the surface. It doesn't tell us why they move, but we do have hunches, rather more than hunches, properly tested and modelled hunches on the computer, and we think it's probably like the skin on the top of a pot of boiling porridge being moved around by the convection of the hot fluid rising.
So how long has plate tectonics been going on then?
Well, we don't actually know that either, but it's certainly been going on for the last 500 million years, and it's almost certainly been going on for a great deal longer than that. We don't know whether it was the original way that the Earth deformed when it started 3,000 million years ago or so.
Millions of years from now, the moving plates will have carried the continents to new locations. Flying the Atlantic will take longer. But if your aunt in Australia is still alive in 50 million years' time, the good news is that she'll be 2,000 miles further north. There are some changes the Earth has no control over. One is the ebb and flow of the seas. governed from 250,000 miles away by Earth's companion, the Moon. The Moon isn't a planet in its own right because it circles the Earth and not the Sun. But it's an important world, nearly 1/3 the size of our own planet. And it's a mere hop across space, something that has always tantalized mankind. Filmmakers started planning the giant leap long before it became possible.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. It's one small step for man, one giant leap for mankind. Houston, you're looking good at 2. Ping, Zags, and Miss Finn all agree.
Some way, when those two Americans stepped on the moon, the people of this world were brought closer together.
It was a most exciting evening. I can remember sitting in a sitting room of a friend, a postgraduate friend at college, and looking out of the window at the moment they landed on the moon, and we could actually see it. And here was something I dreamed of really since I read my first science fiction book actually, which was when I was about 10.
Something fantastic, I think, that was the sort of thing that one always imagined might actually happen, but never believed it would.
Did you watch it on television?
Yes, I watched it on television, yes. I think like most of the rest of the world.
We all left our jobs and went into the the president's room. He had a television set, and we were watching it, and we just found it quite difficult to believe that this had actually taken place.
America's trip to the moon revealed it to the world in a new light. No longer could anyone imagine it was made of green cheese or romanticize over the man in the moon. The moon myths and mysteries we grew up on are now just relegated to library shelves, gathering dust.
You know, for centuries people have been fascinated with the face of the moon. They've imagined all sorts of things there.
Historian Enid Lake in the library of the Royal Greenwich Observatory.
But I suppose the one that most people saw, and this is a batch of drawings that ordinary people have done, and the one that most people seem to see is the man in the moon, which is the one we're most familiar with.
He doesn't look very happy in those pictures.
Well, no. Many people thought that the man in the moon was Cain.
Who was banished?
Who was banished because he was the first murderer.
Oh, I see.
Some people saw a lady.
Now, she looks incredible. She's real French Renaissance with her hair in curls and that lovely Gallic nose.
Right.
You can see anything, can't you?
You can see anything that you want to. But one animal that was particularly associated with the moon was the hare.
There he is.
Right. The moon was a very benevolent goddess, and she wanted to send a symbol, a sign to man that there was hope for mankind. And the message was that as she, the moon, could wax and wane and rise again, so mankind would rise and fall, but rise again. But we don't know whether the hare was malicious or forgetful, because that wasn't the message that he delivered. The message he delivered was that as the moon waxed and waned and died away, so would mankind.
Oh, no.
And the moon was so angry that she picked up a hammer, she hit the hare and split his lip. And the hare retaliated, and he scratched her face. And that's why the moon's face is marked right to this day.
I don't know your mind of it.
There it is.
It's amazing, actually, when you look down and you see all sorts. The first astronomers to turn telescopes to the moon were almost as romantic. They saw the dark patches as seas, and only later realized they were dry, desolate plains. They went on to chart the moon as thoroughly as our own world. With the coming of the space age, it was the obvious place to go. January 1959, and Russia's Luna 1, in a gallant display of fireworks, just manages to make it off the launch pad bound for the moon. It misses by 4,000 miles. But 8 months later, with Luna 2, the Russians score a direct hit, and this cosmic football becomes the first man-made object on another world. Before the world can get its breath back, they're at it again with Luna 3. Just weeks later, it nips behind the moon and pulls off the biggest scoop of all, pictures of the moon's hidden far side. The Russians are well on the way to making the moon their own. But would America let them get away with that? If the Russians could send space probes to the moon, then Uncle Sam could go one better.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
And so America blasted off into space. It wasn't long before they too were hurling spacecraft and billions of dollars in the direction of the moon. Meanwhile, a hand-picked bunch of ace American test pilots started training as geologists. One of them might be the first man to set foot on the moon. Once you get there, you've got to have something to do, and you've got to know what you're looking for.
Pumice, on the other hand, has some definite phenocrysts throughout.
We made very capable geologists out of all of them. I don't think normal graduate students in geology get anything like as good training as the astronauts got, and they're very, very clever and very motivated people, so they learn very quickly. We went on a trip to Iceland, and they interpreted a very complicated area in Iceland, and we were there with the guy that had investigated it for many years. They came up with a different answer. They were right and he was wrong. That gave me some confidence in the fact that they could do the job well on the moon.
The astronauts rehearsed their every move, and America steadily grew more confident it would get there first. But the Russians soon showed who was boss. Luna 9 was a breakthrough. It soft-landed on the moon and sent back the first ever pictures from the rock-strewn surface. Days later, the first lunar orbiter beamed back the anthem of the Communist Party from 250,000 miles away. Russia was almost there, but not quite. It was an American who became the first human to see the Earth from the surface of another world. 8 years and 2 months on from Kennedy's commitment, Buzz Aldrin poses for the picture of the century. And with Neil Armstrong's small step, the space race came to an end.
The engine's now building up to 7.7 million pounds. All engines running. Launch commit and liftoff. We have a launch commit and we have a liftoff. The swing on.
Over the next 3 years, 10 more astronauts set foot on the moon, making it America's own.
We got it done. Roger 5 Jim, and we're sailing free.
And I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns.
Makes you proud to be an American, Tony. Look at the size of that biggie. It is a biggie, isn't it? It may be further away than we think.
No, it's not very far. It was just right beyond you.
You just covered it up. Got it. I got it. They're putting it in here with it.
The astronauts found that the moon rocks were rich in valuable minerals like titanium and aluminium, metals which could form the basis of a profitable moon mining industry in the future.
Do that well.
The astronaut's geology training certainly paid dividends.
Here you get permanently shattered soil. How about rolling that one over? No way. As you come around there, there's a rock in the near field on this rim.
They poked and prodded its surface, took its temperature, and monitored it for moonquakes. All the evidence suggested that the moon was as dead as a dodo.
We're getting home again, jiggity jig.
But hostile though the moon undoubtedly is, the astronauts showed us that it is possible for us to live and work on another world.
What a ride, what a ride.
In 1972, man left the moon for the last time and headed homewards to the blue planet. Man brought back with him not just rocks for the geologists on Earth, but also questions about the moon that are still, at the moment, unanswered.
Sort of the ultimate question is, where does it come from? That's almost a religious question, because there are the ideas that it formed at the same time as the Earth, that it was pulled out of the Earth, that it was captured, it was an asteroid that came by and the moon grabbed it. All these ideas are still in very active contention. The latest idea is that a great impact took place, and the splash from this impact is what went out and formed the moon.
And will you find out by going back?
Yes, we think so, because it should leave its traces, and we can have chemical and age data that would help settle this question. But as in most religious issues, it will probably engender a great deal of debate.
And another debate is simmering. Fired by the discoveries of amateur astronomers, some scientists take seriously the notion that the moon isn't dead.
Aristarchus is looking bright tonight.
The Cook family wouldn't be the first amateur astronomers to upset the professional apple cart.
All that detail from here.
It's amazing. They say the moon is completely changeless, but when you look at it through a telescope like this, you can see differences. Now, you're an amateur family of astronomers, and you've been looking for how long?
About 12 years, I think, and it's amazing the sort of things that we can see. I mean, we've really got the time to observe the moon.
The Cooks have taken extraordinarily good photographs of the moon's surface. And like many amateur astronomers who keep the moon under scrutiny night after night, they've observed unexpected changes there.
There's a lot of colour that you observe. Some of it is to do with the atmosphere, but there is some colour that we feel is not to do with the atmosphere.
What's going on?
Well, it's very difficult for us to know. Really, what we're doing is we're observing and we're reporting what we see. It could be due to sort of little moon quakes, could be due to little emissions of gas disturbing the moon dust. Could be a lot of things.
Landslides, I feel sometimes too, which would cause obscurations, which we do see quite often.
So it's beginning to look that despite what we've all been taught, people like you who are able to look at the moon every night are beginning to tell us that the moon isn't perhaps quite as dead as we have learned to believe. Is that right?
Oh, you're absolutely right.
Let's have another look at it, shall we?
That's right.
Wow. You can still see that bright rim along the edge of Aristarchus.
We have reached the moon, but we've hardly begun to explore it. It's still a place of challenge, a world which is in stark contrast to its companion, the gentle, living blue planet. Most of all, the moon has been an inspiration to us. It has led us to reach beyond our own planet, to aim towards our fellow worlds, and perhaps one day, further still.